Hi, my name is Andrew Rafferty, and this is my introductory video for ACTE651. Here we go. So a little bit about me. I graduated from York College with a degree in secondary ed general science. This is my fourth class in Millersville's STEM curriculum assessment program. Currently I teach chemistry at West York Area High School, which is also the high school that I graduated from, and I coach the York Polar Bears, which is a special needs ice hockey team. And I just signed up to be the head coach for West York's Unified track team, which we are starting this year. That is a track team which is composed of regular ed kids and special education students, really trying to push an inclusive environment. So my first slide, how do students learn science? So Neil deGrasse Tyson is one of the people that inspired me to become a science teacher. And he had a really good video where he talked about every child grows up as a scientist. They're digging in the dirt looking for worms, banging on pots and pans to seeing what different sounds they make. Something happens along their educational journey that makes them lose their passion for science and curiosity. So what are we doing that causes that? I believe in inquiry-based science, and I will talk about that a little bit later. And one thing that I see a lot as a chemistry teacher and as somebody that has a big passion for physics is that kids come into these classes very, very turned off by science and scared of what they might be encountering. And by the time they leave, chemistry and physics are two of their favorite classes that they've had. So just that mindset that we have as a collective that seems to fear or push away science. So that's one of the barriers, and some other barriers to science learning are like we talked about in the readings, the misconceptions that the students have when they enter the class. One of the good examples that even I had when I walked into physics, and it's one of the things that really sticks out in my mind to want to become a scientist was, well, yeah, if I drop a textbook and a piece of paper at the same time, they're not going to hit the ground at the same time. But then when my teacher put the piece of paper on top of a textbook and dropped them, they both hit at the same time. Just to show how gravity does affect all things in acceleration in the same way, but air resistance is a problem. And separating those two, gravity from air resistance, is what they talked about in the reading. What I see a lot, especially kids coming up from our middle school, is they want that instant gratification. They want to be able to just find the answer, put it down, say they're correct. They don't care how they found it. They just want the points. And a lot of the stuff that they've done in the past is a lot of memorizing and then regurgitate it back out, forget about it, and never come back to it again. So when they get to a class like chemistry where they have to problem solve or remember concepts that last throughout the course, it's quite a problem for them. And then state testing in biology. I mean, the stuff that our bio teachers have to do instead of running some fun inquiry-based labs is sad. So in my classroom, I try to always start with an inquiry-based lab. I really try to inspire science for the kids, and we started a program called Random Acts of Science during Lunch and Learn, where we just go around and do fun science things to make the kids excited about science. And my STEM perspective, I'm still trying to develop it. I definitely lean towards the S because I'm a science teacher and I want to learn quite a bit more, especially with Project Lead the Way coming to West York next year.